Okay, sorry, so my video cut off. So back to C. If C is positive, it just simply goes up. If your C is negative, it simply just goes down. Okay, so that's pretty simple to remember. Okay, so if it's going up, we've got a positive C. If it's going down past 0, we have a negative C. All right, so now on number 10 in your workbook, you will need to write this down because this is so very important. So first, we are going to write the rules for A. So first, I want you to write A equals. Okay? There's 3 rules. If A is between 0 and 1, then the graph is wider than x squared. Okay? You may also see this written as being vertically shrunk or compressed. This is how I want you to remember, and I'm going to write in blue for this one. If you are less than 1 year old, okay, so from the time you were born until you hit 1, you are a fat baby, okay? You are wider, okay? Silly way to remember, but I promise it helps. All right. Going to erase this and do the next one because I'm out of room. Remember, you can pause the video to write this down. All right, I'm going back to red. And next one is if A is greater than 1, then the graph all right, next I'm going to do when A is greater than 1, okay? Then the graph is more narrow than x squared. Sometimes Agile Mind will say this is vertically stretched. The way I want you to remember this one is when you were older than 1 year old, you are going to start to get taller. All right. Last one for A. When A is less than 0, meaning it is a negative number, the graph does 2 things. First, it is reflected across the x-axis, meaning it flips. Okay, that's the first thing it does. Then, the second thing it does is if that number is between 0 and 1, it is fat. And if A is greater than 1, then it becomes tall. All right. Now we're going to talk about C. And remember, C is the easy one. So, C, if C is greater than 0, meaning it is positive, the graph moves up the y-axis. Okay? If C is less than 0, meaning it's negative, the graph moves down the y-axis. So, A and C, those are some rules. You got to know those rules. We're going to do some practice questions where you'll be able to see what I'm talking about in just a sec. All right, let's see. I want you to flip to page 68 in your workbook. And I want you to go to page 10 on Agile Mind. So page 68 in your workbook and page 10 on your Agile Mind. All right, so this is also a little confusing. So, on your computer, I want you to play around with this H. You notice that if you move this to the right, my graph actually moves where? To the left. If we go back to 0 and we start moving to the left on the positive, or on the negative numbers, you notice it moves to the right. So we're at 0, and my H is positive, but it's going where? To the left. You start at 0 and you go to the negative side, negative numbers, it moves to the right. Okay? So, I want you to go to page 11. And these are the same questions on page 68, number 13, 14, and 15. Okay, so number 13 says, how does the graph of y equals x plus h squared compare to the graph of y equals x squared when h is positive? So, I'm going to click check. And it says, for positive values of h, the graph of y equals x plus h squared lies h units to the left of the graph. It's kind of opposite of what your brain thinks, okay? So you want to write that down for number 13. Next, on number 14, it says, how does the graph of y equals x plus h squared compare to the graph of y equals x when h is negative? So since h is negative, it's really going to move to the right. Pay attention to this. What does that mean? absolute value. Absolute value means it is always positive, which is where this plus sign comes from. All right, next is number 15. And number 15, I'm gonna swap over so I can write on number 15. I want you to star number 15 on your paper. So, this function rule right here is the parent function of a transformed x squared graph. And we know this has to be quadratic because of this square. Okay? So, we are writing two rules for this. This is one we really want to pay attention to. When h is positive, the graph y equals x minus h squared lies h units to the right. Okay? An example. Make sure you write this part down. H equals 4. Okay? You are literally taking this 4 and you are plugging it in for H. You keep that x minus whatever there because that is the function rule. When you see x minus something, you are always moving to the right. Okay? Now, I'm going to erase this and show you the other one. When h is negative, the graph y equals x minus h squared lies h units to the left. Okay? Now, if I say h equals negative 4, I am plugging in a negative 4. But what do you notice? These two negatives make a positive. Okay? Don't forget, you can pause this video anytime you need to. All right, number 16. Graph the function of f of x equals x minus 3 squared. How does this graph compare to the parent function of y equals x squared? So I want you to sketch me a graph on your paper of y equals x squared. Looks something like this. Okay, now I'm going to change colors and I'm going to go to blue. And I'm going to write my transformed. So f of x equals x minus 3 squared. Okay, that 3, just this 3, it is a positive 3. So h equals 3. Since it is positive, this number 3 is positive. I am moving to the right 1, 2, 3 times. Blue is my transformed graph. Remember, x minus 3 squared moves right. Okay? Now, I want us to go to number 17. And it says, how do the parameters a, h, and k of the general equation y equals a times x minus h squared plus k affect the graph of a quadratic function? So, above this right here, I want you to write vertex form of quadratic function. Okay? All right. We wrote on number 10 that A tells us if the graph becomes more narrow or it is vertically stretched or if it becomes wider, which means it's vertically shrunk or compressed. H is our horizontal shift. And back up. K is our vertical shift. So K works the same way as C did in number 10, okay? So, I want to do number 18 together. All right, it says for each graph, write the equation of the quadratic function in vertex form. Okay, also describe the transformation from the parent function y equals x squared. So, before you start, you need to notice that going vertically up and down, the tick marks are going by 1. Horizontally on the x-axis, they are going by 0.5. Okay, so out beside, I want you to write A equals, H equals, and K equals, okay? Over on the side, I want you to write H, K equals center, okay? So I want to find the center of this parabola. What is that point? I have to go over one whole time because this is 0.5 and this is 1. So I'm going over -1 and I'm going down 1, 2, 3. Okay? Now, does that graph look any taller or any wider than an x squared graph? No, it does not. So your A is just going to stay as 1. Now we have A, H, and K. So we are taking that information and we are plugging it in to this equation. So we are simply saying y equals 1 x minus -1 squared plus k. Well, these two negatives make a positive. So now I have y equals x plus 1 squared minus 3. Okay, I'm going to erase this right here and go ahead and put a minus 3. And it is negative 3 because it's going down 3. Now, why did I not write this 1 right here? I don't really have to. Okay, it's just 1. So this would be my answer. All right, I want you to do B. Okay, so I want you to take a minute and do B. Pause the video and do B. And I'm going to go ahead and go to C. All right, what do you notice about C? It's upside down. So since it is upside down, you know that A has to be negative. Okay? Now, H, K. For H and K, we've got to find the center of our parabola. Here's the center. So starting at 0, horizontal shift goes with H. I'm counting over 1, 2 to the left, so a negative 2. And I'm counting up 1, 2, 3, 4. Now, does that graph look any taller or any wider than x squared? No, so it's just a negative 1. And it's negative because it is flipped. So I'm plugging in my values. I'm simplifying. And that is my answer. So I want you to do B on your own, and we'll talk about it in class. All right. Okay, I'm going to go through the more practice with you. Okay? So I'm going back to Agile Mind. I'm clicking to the end of number 13, and I'm hitting my green arrow to bring up my first question. Let me get there. All right. Match each equation to its graph. So you have 3 graphs and you have 5 answers. So you're not going to use 2 answers. Okay? So I'm going to write a few things to help you. This graph is going to have a negative sign out front because it is flipped. Okay? These 2 graphs are going to be positive. This graph is wider. This graph is wider. And this graph is more narrow. This graph seems to move down. This graph seems to move down. And this graph seems to move down. Okay? So, it is your job to use the rules that I've given you on numbers 10 and number 15 in your workbook to help you. Okay? I've given you a few hints. You can always, if you have no idea, you can do 2 things. You can message me. You can ask me to help. Would love to help you. And you can also graph these on your calculator, or you can go to desmos.com and you can graph. I think actually, if you click this calculator, it says graphing calculator. It brings up Desmos. So you can go ahead and type that in and match your graphs. Okay? All right, on number 2, this one's a little tricky. So, it tells us f of x equals x squared. And g of x is negative 2 times f of x plus 3. But what do we know f of x is? We know f of x is x squared, so I'm literally plugging this in, guys. Y equals negative 2 x squared plus 3. You were using this function rule now. You were taking these values and you were plugging them each in separately for x to get out your y. So I'm going to do the first one with you. Negative 2 negative 2x squared plus 3. The first one tells me to plug in a negative 2 for x. Negative 2 times negative 2 squared plus 3. Negative 2. And then we have negative 2 squared. So that means a negative 2 times a negative 2 is a positive 4 plus 3. So I have a negative 8 plus 3, which is a negative 5. All right, you will do the same thing for negative 1, 0, and 1. Remember, on more practice, you get 3 tries. All right, the last question we're doing today is which of the following graphs could be the graph of the function g of x equals negative 2 times f of x plus 3 if f of x equals x squared. So it's wanting you once again to plug f of x where it says. So our function, y equals negative 2x squared plus 3. Since you have this negative right here, you know it's going to have to be flipped. Since there is a 2 for my a value, you have to know that it is going to be taller. More narrow, same thing. And since this 3, you know it's going to have to go up 3. All right, I'm going to upload this. If you have any questions, please, please, please let me know, okay? I also uploaded a link onto our teams to give you some more practice and some extra things to help. Have a good day.